I'm going to teach you how to basically filter out different rows by values in a column. So for example, let's say we want to get every single one of these rows whose score value is 3. I could filter out all the rows with the score value of 3, or we want to get all the rows where the sex of the individual is male. I could filter those all out so that we only get male results and we don't get female results, right? So that's what we mean by filtering. The next thing I could do is actually sort the data frame, or give a printout of a sorted data frame by whatever criteria. So I could sort it by the age, we could sort it by the name, for example, sex, the score, and we'd sort it by the score in ascending order. So it'd start with the lowest scores to the highest scores, and the rows would be sorted that way. Right. I'm also going to show you how to describe a data set, or do something called describe on a pandas data frame, which just gives you a bunch of like statistical analysis things that might be useful to you. Right. I'll start off with filtering. Well, first of all, actually, I'll just run this just so that we've got our variable. You can see we've got our data frame loaded in. And now I'm going to show you how to filter through. So I'm going to say that I want basically all of the scores that are equal to 3, right? So I want the rows where the scores are equal to 3, right? So I'm actually going to use the, oops, don't know how that happened. I'm going to use the .loc attribute, and we're going to say that we want the data frame, which is the scdf, and we want to say that we want the score column, right? And we're saying we want to locate all of the rows in SC where the score is equal to 3, right? And if I run this, what we should get out is sort of an output of all the rows where the score is equal to 3. And you can see that we've only got rows where the score is equal to 3, and so we've located all of the rows in this data frame where the score is equal to 3, right? I can also do it so that we locate, I don't know, all of the scores that are above 3, for example, just because why not? So we can say that, and we can use a comparison there, and this will get quite a lot more rows. Most rows are above 3, so most people scored a score of above 3, right? Good for them. Now, these are obviously numerical, sort of numerical filters, but we can also filter, we could filter names, or we could filter sex. So I could say sc_df.loc, and I could actually filter by name. So we'll filter by the name Afsana, just so we can get Afsana's row. Now, you're probably looking at this and thinking, why do we want just one row? Okay, in this case, we've only got 19 data points, so there's only one row with the name Afsana. But if we had, a data frame with 20 million different entries, we'd probably have duplicates. We'd probably have more than one person called Afsana, depending on what region of the world we're in, right? But there's a lot of names that would be duplicate, right? And another thing we can sort or filter by is by the sex, so we can get only males if we want. Oops, scdf.loc, sc_df, and we're going to filter by sex, and we're going to say we want it to be equal to male. Let's just see what we get from that. And you can see we get all of the males printed out. And so we can filter like that. Okay. Now the next thing we're going to do is sort, and we're going to say that we want, for example, I don't know, to sort by the values of the scores. And when you sort, it's actually default ascending order, and you can sort by both strings and by numerical data, right? So the first thing I'm going to want to sort, oops, that's not it at all. We're going to use sort values. The first thing I'm going to sort is actually by the score, right? And when you actually run this, by default, it sorts in ascending order. So you can see that it starts with the lowest score, and then it increases to the highest score, right? We might want to start with the highest score and go to the lowest score, in which case we actually have to change the default to be descending or to be not ascending, as will become a bit more clear. So we say that we want to sort by score. We're going to say that ascending is equal to false, which will give us a descending printout, or a bunch of descending values. Start with the highest value there. Now, as I said, we can also sort by strings. I'm going to sort by string at the moment. We're going to sort by the name string, and we're going to sort by ascending order, i.e. the default. And you're going to see that Afsana comes out on top in that sort. And then we're going to sort by descending, and we'll see who comes up. I think it's probably going to be my name, because I haven't seen anything that's higher than Y yet, but we'll see. It's probably going to be Yusuf. It's probably going to be Yusuf. And now Yusuf's on top in that order. So you can see Afsana's on top in the regular order, in ascending, and Yusuf's on top in descending order, right? Now you're probably thinking this sounds great and all, but what if I want to sort by maybe say 2 different columns? So maybe you want to sort by sex and then by score, or by name and then by score, etc., etc. Well, we can do that, and we can do that like this. So we say sort values, and we're going to say by is equal to, and we've got to make a little list here. I'm going to say name and then score, right? Oops, got to put that in there. I think this should work. Yeah. So you can see it's sorted by the name order first of all, right? But Afsana is the top result, and then it sorts by score, right? Not the best, not really seeing much of a difference here because it's prioritized the name in ascending order. We could do sex and then name, so we could do sc_df.sort values. I'm going to sort them by, we're going to say, what was it? We're going to say sex, actually. Say sex, and then we're going to say name. Let's see what this gives us. Okay. Oh, we need an equals there. Let's see what we get here. Now, we get, first of all, the females, because F is actually a smaller value than M in string comparisons. So we get all of the female names in order, and then we get all of the males straight after the females in name order, right? Because we've ordered first off by sex, so we start with all the Fs, and then we've ordered by men, so we get all the males. But then after we've sorted everything into Fs and Ms, within that sort, we're now sorting by name order in ascending order, right? So we get all the female names in ascending order, and then we get all the male names in ascending order. Now, let's say you don't want this to be in ascending order, right? Maybe you want them both to be in descending order, so you want to start with males, and you want to start with Yusuf, for example. What we want to do there is the following, right? So we want to do our sort. Score values. I'm going to sort once again by is equal to sex, and then name. Oops, name needs to be in capitals. And we're going to say ascending is equal to false, right? Oops, that needs to be closed off there, and that needs to be a comma. Thank you very much. That should be okay now. It's still saying something's wrong, but I think it's all right. Valid syntax Y. Okay, yeah, that's why. That makes complete sense. That should be fine now. And if we run this, you guess what we get? That's right. So, because ascending is equal to false, we've got all males first instead of females, because M is a larger value than F. And the names are sorted in reverse order. So, the name that is comes last in the alphabet is the first name, right? You can see that's true for both of them. You can probably see a little problem here. Maybe you just want to get all the males, right, and then all the females, but you don't want the names to be in descending order. You might want them to be in ascending order. So you might want one to be sorted by ascending order and the other to be sorted by descending order, right? Now you can actually choose which is sorted by what and differentiate between them. I'll show you how now. So we can say that we want to sort by sex and by name, and then we can say ascending is equal to this, and we're going to say we want the first one to be false, i.e. we want the sex to be sorted in descending order, and then we want the second one to be true, i.e. we want the names to be sorted in ascending order. And now we get all of our males first and all of our females, right? And the males are all in ascending, the males' names, are in ascending order. The females' names are also in ascending order, but the sex is in descending order, i.e. males first, right? So those are some of the ways that we can sort our databases, our data frames by different columns, right? We can also save this. We could save what this sort that we've got as a new data frame, and then we could take this to be our new data frame and use that data as we please, right? If we wanted to, we could even, filter all the male and female and put them into two separate CSV files. So we got one for males and one set of statistics for females, etc., etc. There's loads of stuff you can do with that. Now, the last thing I said that I'd show you is the describe function, and what this does is basically just gives you a bunch of statistical information about a data set. Just consider it a free goodie, right? If I run that, data frame has no object. Oops. Object has no attribute. Yeah. Describe, if you spell it right, it'll work. And this will give us the sort of count, how many of something appear. It'll give us the mean value, the standard deviation, the minimum, all these statistical analysis. Unfortunately, it only works on score, because the score values are the only values that are integers or floats, which can have sort of statistical analysis applied to them in that sense. Now, age is actually a string. I won't get into why, but it's basically to do with this. Maybe you'll figure it out. But it's a string, okay? It should be an integer, but I'll solve that problem another day. And yeah, that's pretty much it, guys. Thank you for watching. Hope you enjoyed.